Alright, hello there everyone. My name is Alex Winling and I shall be here today to bestow some math knowledge upon you. So today I am currently in the Functions Modeling Change Preparation for Calculus book. And we're going to be going over problems number 37 and 41. So 37 here says, using the factored form, find the formula for the parabola whose zeros are x equals -1 and x equals 5, in which passes through the point -2, 6. So the first thing you got to realize is we have 2 points here. We got -1 and 5. So immediately we can easily put this into an equation. What equation or formula do you use most in this situation? It's the factored formula. So we're just going to write that out real quick. We're going to have y equals a times x plus 1 and x minus 5. So how we got these two values here was the 5 in our equation. Remember, we had 2 points of -1 and a point of 5. The equation in here is x minus and then the value. So for us, here is 5, and we had -1, so that is a double negative, making it a positive. Now we had the other point here of -2, 6, which this whole formula here passed through this point. So what we could do is we could just put this x here and put this y here. From here, all we have to do is plug these numbers into the equation. So we're just going to plug in 6 for now for y. So we're going to have 6 equals a times x plus 1, parentheses x minus 5. Alright, we're going well here. Next thing we're going to be doing is we're going to be plugging in the 2 for the -2 for the x values. So we're going to have 6 equals a -2 plus 1, and then -2 minus 5. From here, all we're going to do is solve inside the parentheses. It's just simple addition and simple subtraction. So we're going to have 6 equals a -2 plus 1 equals -1, and then we have -2 minus 5, which equals -7. From here, we're just going to multiply the two values within the parentheses here. So we're going to have 6 equals a times 7. That is going to make it into 6 times 7a. To solve for the a value here, which we need to do in order to find, the formula for the parabola, we're going to have to divide it by 7, and that's going to leave a with 6/7. So since we have this value here for a, that means now we can put it back in and find the actual formula. So we're going to have y equals 6/7 times x plus 1 and x minus 5. And that is our whole entire answer in terms of finding the parabola. Obviously, you could, if you wanted to, extend this out more, but that would make it into standard form if I'm not mistaken. But this will do alone because this technically is a formula for the parabola. Alright, I'm going to do this real quick. We're just going to go right up here. We're just going to put 41 here because we are going to move on to problem number 41. Now, I don't know if I could get this quite in the picture. No, I'm just going to read it out to you. So problem number 41 says, a snowboarder slides up from the bottom of a half pipe and comes down again, sliding with little resistance on the snow. Her height above the top edge of the pipe, t seconds, after starting up the side is -4.9 t squared plus 14t minus 5 meters. A asks you for what is her height at t equals 0. So we're just going to write the equation down here for all of you to see. So it's -4.9 t squared plus 14t minus 5. So one thing I would like to say is kind of a fun little fact is this right here is actually half of the acceleration of gravity. The acceleration of gravity is equal to -9.8 meters per second squared, if I'm not mistaken, because that is referring to acceleration. So yeah, that is a kind of accurate number. If you've ever taken physics in high school, you will know that number very well, especially -9.8. Anyways, losing track, A is asking what is her height when the time is equal to 0. Well, all we have to do for a here is just put in negative 4.9 and then put a 0 here. As you know, 0 squared is just 0. Then plus 14 times 0, which is going to make it into 0 minus 5. So you got 0 plus 0 minus 5. So your answer is going to be negative 5. And that's her height, so you're going to have to label it in meters. So that is the answer for A. Moving on to B, it says, after how many seconds does she reach the top of the edge? And after how many seconds does she return to the edge of the pipe? So, based on this equation here, there is no way you can factor this out. This equation is not factorable, so we have to do it the hard way, also known as the quadratic formula. So one jingle my Algebra 1 teacher taught me is actually the jingle for the quadratic formula, which, yes, I'm going to say for you. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And that is the whole formula there. So for this, we're going to have to plug in the corresponding numbers for it. So if we, actually this x isn't supposed to be x. Technically in this problem it's going to be a t. So we're going to have to do t, negative b, b is 14, so we got negative 14, plus or minus the square root of 14 squared minus 4 times negative 4.9 times negative 5, all over 2a. And 2 times a, so 2 times negative 4.9. We're just going to keep on factoring this out. I'm going to have to get my calculator for this here, so we're just going to, so here we're just going to be doing 14 squared, and that is going to get us 196. So we're just going to do negative 14 plus or minus square root, so we got 196 minus, I shouldn't be assuming that, but I put a minus there because I know that negative times a negative makes a positive, times another negative makes a negative, so we're just going to do that. So we got negative 4 times negative 4.9, actually, times negative 5, hit enter, and that is negative 98. So we're going to do minus 98 all over 2 times negative 4.9. You're going to have to do the math for that as well. So 2 times negative 4.9, that's going to give us negative 9.8. So we're just going to keep on reducing this. So t equals negative 14 plus or minus the square root of 196 minus 98, so 196 minus 98, and that is going to give us 98 all over negative 9.8. So now we can find the square root of 98 here. So second x squared gives us square root 98, hits enter. 9.89949. We're just gonna stop there and do how much should we go by? I think 4 decimal places will be good enough. So 9.8995. Let's kind of leave it there. So we're gonna have 14 plus or minus 9.8995 divided by negative 9.8. From here, you're going to have to split it off, as I like to say. And over here, we are going to have the equation of t equals 14 plus 9.8995 divided by negative 9.8. If we do the simple math here, we do 14 plus 9.8995. That gives us 23.8995, so we're just going to do right here, t equals 23.8995 divided by negative 9.8, and if we take that number that we got in our calculator and divide it by negative 9.8, that is going to give us, actually, I shouldn't have a negative there somewhere. That should be a positive, not a negative. Because you can't have negative seconds in the air. So for now, I do not understand what I did wrong there. Oh, you know what? Actually, I got it right here, I think. This is supposed to be a negative 14 here. So negative 14, negative 14. So now, this is actually going to change this here. See, I even make mistakes sometimes, but I gotta make sure I catch them. So negative 14 plus 9.8995 is going to give us negative 4.1005. So negative 4.1005. Now if we divide that by negative 9.8, that's going to get us 0.41841. We're just going to round it up. So our time here is going to be time equals 0.41842 seconds. So that's one of them. On the other hand, though, take those off. Up here, we're going to have to solve the other way. So we're going to have time equals negative 14 minus 9.8995 divided by negative 9.8. So if we do, here we go, negative 14 minus 9.8995, we're going to get negative 23.8995. So write this out, divided by negative 9.8. We're just going to divide this number by negative 9.8. Now it's going to give us a time of 2.43872 seconds. So that is, the question asked though, after how many seconds does she reach the top of the edge? Well, this one is quicker, and it takes a quicker amount of time to reach the top of it than landing down. So this is going to be when she reaches the top. So that is when she reaches the top. Here, reaches top, and then this is going to be landing. So those are your times for when she lands. She lands after 2.43872 seconds after launching off, and for here she reaches the top 0.418425 or 42 seconds after launching. And then for C, it asks how long is she in the air. Well, that's pretty easy. If you have your landing and your point at which she reaches the top, it's pretty easy. All you have to do is do this minus this. So we're gonna do that real quick. I'm just gonna try our, actually we could do it right here so you can see. So we're gonna do 2.43872 minus 0.41842. We're gonna make this easy on ourselves because I have my calculator here, and we're just gonna do 2.43872 minus 0.41842, and that gives us a time of 2.0203. So that is 2.023 seconds in air. And that is how you solve problem number 41. This is the answer to letter C. These are your two answers to letter B. And then at the top, right here, this is for letter A, -5 meters. That is it for how to solve problems number 37 and 41 within the Functions Modeling Change, a preparation for calculus 5th edition book. I hope you enjoyed the tutorial, and yeah, I hope you actually learned something from this. But for now, see you later.